Okay, this is lesson 7.2, velocity. This is the third example. The other example is very similar to things we've done before, so we're going to focus on this one. It's a little different. A river is 2 kilometers wide and flows at a rate of 6 kilometers an hour. Anna is driving a boat, which she has a speed of 20 kilometers an hour, okay, in still water, and she heads from one bank to the other in a direction that is perpendicular to the current. So think of the current going directly down the river, and she heads directly across the river. The marina is directly across the river from where Anna starts. That is not important, the marina part, until I ask you the question of how far down the river is she from the marina when she gets there, or gets to the other side of the bank. So, what do we always do first? Draw a picture. Yeah. That's why you learn how to draw in kindergarten. It's so important. There you go. So we have our river, and we know that Anna is going to be driving her boat across the river. Okay. Now, there's 2 pieces of information we have here. And what I'll do is I'm going to set up 2 triangles to represent both of them. One of them represents our speed along the river. The other one represents the distance in the river. Okay. So, let's change the color here. Speed we'll do in green for go. Okay. So, the distance across the river was what? Anyone remember? 2 kilometers. How fast was Anna traveling across the river? How fast did her boat go? 20. Her boat travels at 20 kilometers an hour. Okay? So the distance is 2. Her boat travels at 20. Next part, how fast is the current? Okay, so the current is 6. And the current is heading what direction? Downstream, we'll say. Okay, so the current is heading this direction at 6 kilometers an hour. Okay, so luckily I've color coded this for us, but we kind of got to create a triangle out of one of these situations. Okay, so the one that I have enough information for to create a triangle is the one that has to do with speeds. We know at 20 kilometers an hour she's heading down the stream, and the stream itself moves at 6 kilometers an hour. So we're going to be putting these vectors together, okay? Kind of like we're adding them to find out what will happen if she tries to travel directly across the river. Okay? Our resultant vector is what is going to come of this situation. So as she travels at 20 kilometers an hour across the river itself is pushing her boat downriver. So she's not going to actually get to where she wants to, or at least where she's aiming at. The resultant vector we will call red. Or call red. We'll color red. Okay. That's black. Okay. It's going to be black. So our resultant vector is where she's going to end up down the river. Now that's with speeds. The triangle we created is with speeds, but the first question asks us how far down the river does she end up? Okay? And what we can do from that is our distance one is 2 kilometers. Well, we know that what we're essentially going to build here is a similar triangle. So we're going to take this line. This one's going to come down here, and this here. So what we have between the 2 of these are similar triangles. The angles inside of the triangles are all going to be the exact same. The only difference is essentially one is dealing with distance while the other one's dealing with speed. If we were to take them as strictly magnitudes of each other, it looks like one triangle is much larger than the other. One measures 20 in magnitude while the other measures 2 in magnitude. But the angles are the same, which is very important, which means we've created similar triangles. So what I can set up now is we're trying to figure out how far downriver she ends up. That's essentially our x. How far down the river does she end up due to the river's current pushing her along? So we're going to set up a similar triangle. And what that means is I know that 20, that's my speed, divided by 6 will give me the same ratio as 2, which is the distance, divided by our x. Okay? So I've set up a similar ratio. The ratios are going to be the same here. I'm going to flip the ratios. I should have done that in the first place, so that the x is on top. Okay. And where we're going to go for there is we're going to solve for our x. What we're going to get is 12 divided by 20, which is equal to x. And remember, x is in kilometers itself. So x is equal to, what does that divide to? 2 is 6 out of 10. 6 out of 10 is 0.6. 0.6. So she is 0.6 kilometers downstream from the marina. Okay? This is 0.6 kilometers. That's what we figured out in our similar triangles here. So the current has pushed her 600 meters downstream from where she was aiming. Okay? The second question is, how long will it take for the boat to cross the river? Okay. How long will it take for the boat to cross the river? Well, again, we're working with our triangles. We're going to work with our distance one and refer to the speed she travels at. Okay? So we go on the assumption that she can travel at 20 kilometers an hour. But we need to know how far she's traveling. Well, she's actually not taking the route that we thought she was going to take. We know she wanted to travel directly 2 kilometers across the river. But due to the current, she ends up traveling farther downriver because it's pushing her on an angle. So we actually have to figure out how far she travels in her boat. What would I use to solve for this? Pythagorean Theorem. So 2 squared plus 0.6 squared is equal to, we'll just call it c, our c squared. C is going to be equal to, or c squared looks like is equal to 4.36. And when we square root that number, 2.09. So the distance she travels downriver is 2.09 kilometers, and that's what our c is essentially equal to. Okay? Now, what we want to do here is figure out exactly also how fast she's moving across this river, which will be very helpful. Her speed of the river is also going to change because her boat goes 20 kilometers an hour, but the current is pushing her. So a resultant vector is also going to give us a new speed at what she's traveling at when she takes that course. Okay? So in other words, what we're trying to figure out is we do know how far she travels. We now have to figure out how fast she travels that same route. Okay? Same idea. Pythagorean Theorem, just different numbers. So we're going to take our 20 squared plus 6 squared is equal to, we'll call this the resultant vector. We'll call it vector A. Okay? Is equal to the magnitude of vector A squared. 436. Oh, that's really cool. Oh, that's slow. I didn't realize that. Is equal to A squared. What are we going to get? It's 20.9. Should be roughly the same decimal, just move back one because of our numbers. So the magnitude, or the speed she travels at, the speed she's traveling at is at 20.9 kilometers an hour. So what ends up happening is the river is actually speeding her up. Her boat's going faster than it was able to, but she's also traveling farther than she had previously expected. So we now need to figure out how long it took her to get there. Well, if she's traveling, her distance, so distance divided by speed gives us our travel time. You guys ever seen that kind of set up in triangle form? Yes, no? Yeah, science class, I think they talk about it. Well, her distance in this case is 2.09 kilometers. Her speed is 20.9 kilometers an hour. So her time, being t, will be the division of these two, which is 0.1. So she travels 0.1 hours downstream. What is 0.1 hours? Yeah. It takes her 6 minutes to get across that river, is what we figured out. That was the B part of the question. I'll show the entire page for you here. Okay. So we figured out how far downstream she ended up, which is 0.6 kilometers. It takes her 6 minutes to travel that distance because her boat has sped up to 20.9 kilometers an hour, but she's also traveling 2.9 kilometers, which is different. What did she ask us? Okay. This one is a little different. Okay, question C states, Anna decides that she wants to actually be aimed at the marina. She wants to travel directly across. So we have to change this question a little. I'm going to jump to another page. Okay. So we're still at the same river. But in this question it says that she actually wants to get to where she's going. She doesn't want to end up downstream. Okay. We still know that that distance is 2 kilometers here. What we need to figure out now is how she's going to be able to do that. Well, clearly, if the current is going this way, which way is she going to have to aim her boat? Upstream somewhere. We don't know exactly how far, but we do know that she's going to have to aim her boat upstream from there. So let's say red is where she's aiming her boat. She's going to aim her boat somewhere upstream. Now, how fast can her boat travel? 20 kilometers an hour. Okay? So we're going to assume when aiming her boat up that way, she's traveling roughly 20 kilometers an hour, or what the capacity of her boat is able to do. We're going to find out that she won't end up traveling that speed due to the current, but because her boat can travel at that speed, we say that she's traveling 20 kilometers an hour at this angle. That's the max capacity of the boat. What's happening is the current now is pushing her boat back. How fast was the current? 6 kilometers an hour. Okay? So we've now made a triangle again, another right angle triangle. What we're going to figure out is A, the angle, I'm going to call theta, that she needs to aim the nose of her boat at, and what the resultant speed is. So essentially the vector. We're going to have a direction she's going to be aiming at, and what speed she's going to travel at. So we have our right angle triangle here. We need to find, we'll call this vector x, what her vector x is going to need to be. First of all, we can figure out what speed she's going to travel at. Again, using Pythagorean Theorem, the only difference is we have the hypotenuse we're figuring out for one of the sides. So because c squared is equal to a squared plus b squared, in our triangle we have 20 squared is equal to 6 squared plus b squared, which is 400. Subtract 36 is equal to b squared. B is going to be B. 19.8 kilometers an hour. So her boat has a max capacity of 20 kilometers an hour. She's pushing it to the throttle aimed up the stream. The problem is the current is now slowing her down because it is kind of in her face or in the way she's aimed. So her boat is now traveling at 9.08 kilometers an hour when trying to get across the river. But what angle is she firing the boat at? Well, we have 3 sides of the triangle, which means I can use sine, cosine, or tangent ratio to solve. I'm going to use sine just because those are the 2 givens. I always like working with what was already given in case I rounded wrong, okay? Or my answer was wrong. So, in this case, opposite and the hypotenuse, well, that gives us sine. Sine theta, let's just keep going through this. Sine theta is opposite, which is 6 over 20, okay? Which means theta is equal to the inverse of sine, 6 over 20. What is theta going to be? Anyone know? There it is. 17.5, not degrees. Degrees, not hour. 17.5 degrees. So she needs to point her boat 17.5 degrees north of, directly across, of the horizontal. Or we could say as a measurement of east-north or north-south, we can just reverse it to get that. But essentially that's 7.2.